All right, everyone. I'm going to do another video here, just following up on a previous video where I was doing some preliminary testing, making sure that the PWM signals were generated properly. So now the next phase of my testing is going to be connecting the Prius inverter up to a low voltage battery and just seeing if I can get motor to spin. So here we've got a 2012 Gen 3 Prius inverter that I've swapped the logic board on with logic board from EVBMW, so Damien, Maguire, and Johannes Huebner board. So now I've got everything buttoned up. I've got that logic board installed. I've got the resistor network array updated and used some different 210 kilo ohm resistors in that DC to DC converter resistor array. So I've got all that updated. So at this point I just want to test the system with a low voltage with a 3-phase induction motor. So in terms of battery, what I've got here is pretty simple. So basically these are 2 batteries for my cordless drill. Each one is 18 volts. So they're nickel cadmium, like I said, cordless drill batteries. And what I've done here is I've put them in series, so they have a combined voltage of 36 volts, which I'll then put on the DC bus here in the Prius inverter. So I've already got the logic board powered up here. I do have a pre-charge resistor that I've got in the positive lead to go to the DC positive bus, or the DC positive. And this pre-charge resistor that I have here is 50 watts, 100 ohms. So what I'm going to do here is just, attach this lead from the battery. It's going to go through the pre-charge resistor, and I'm going to charge up the capacitor, and we'll see what happens here. And then after I wait a few seconds and the capacitor is all charged up, what I'll do is I'll clip this lead on here, bypass the pre-charge resistor to get the full voltage and full current out of this battery setup that I have here. So once I do all that, I'll go to my Huebner web page, and I will try to start this thing in manual mode and see what happens. Alright, so here we go. Got the positive lead going through the pre-charge resistor. It's all good. Just a quick verify here on the voltage. Yep. 38 volts there on the bus. So now what I'll do is I'll bypass this pre-charge resistor, clip it in there, slide it off to the side. Now I've got a direct lead to the DC positive here. Alright, so next step is going to be connecting forward in for the logic board. Got that connected. Alright, so now go to the web interface. Alright, so I've got the web interface up here. So I'll start inverter in manual mode. So we've got a message here that is inverter started. Next thing that I'll do is this ENC mode, encoder mode. I'll switch that to AB. Set OK is the message. So at this point, what I'll do is I'll scroll down to the bottom. Whoop, here we go. And then for the slip point, I'll enter a value of 10 Hertz. For the amplitude nominal, 100. Woohoo! All right, so we got the motor spinning here, albeit very slowly. And yeah, so I would say that we've been successful there. Looks like I do have a error here that's den OCUR. I'm not exactly sure what that means. Probably something I need to investigate and see what I need to do to correct that. It looks like the temperature on the heatsink is 89°C, so I am going to shut this off. So I'm just going to go up here. Actually, I'll do it here. Amplitude nominal 0. Hertz 0. All right, so I would say that I've been able to successfully spin the motor, induction motor here. So right now I just have it wired to MG2. On the logic board I do have MG1 and MG2. I have the jumper for those two PWM signals connected. So I guess whenever I do get this installed in a running vehicle, I will connect both of those to the same motor. So I'll do that when the time comes. All right. So I'll just stop the inverter, and I'm going to call that a success. So next item on the agenda here is going to be getting a bigger battery. All right, until next time.